So good afternoon to everyone. Today we will discuss a topic that is a coefficient of correlation. So previous we have discussed about what is meant by correlation and what are the types of correlations. So here we can discuss what coefficient of correlation and what are the methods or in correlation to analyze the correlation. So before knowing that coefficient of correlation, we need to study that what are the methods are there in coefficient of correlation. That is the methods of studying correlation. See, in order to study the correlation, in order to understand what is correlation, and there are some different methods to study the correlation. The first method is the scatter diagram method. Scatter diagram method. The second one, graphic method. Second one is a graphic method. Third one, algebraic or mathematical methods. So there are mainly three types are there. So scatter diagram, graphic method, and algebra or mathematical methods. So within the mathematical method, there are four types of methods are there. In the first one, in the third, Karl Pearson's coefficient of correlation. The first one is a Karl Pearson's coefficient of correlation, which is very important. And the second one, there's the Spearman rank correlation. Spearman rank correlation. So there are other methods are there. There is a concurrent deviation method, and fourth one is a method of least square. But most of the popular methods are two, that is a Karl Pearson coefficient method and Spearman rank correlation method. See, within the four, the first two, that is a scatter diagram and graphic method, which we can able to find out that what is the relationship between the two variables. But we cannot come to know that what is the exact relationship between, nothing but how much the degree of relationship between the two variables. But when you are calculating them mathematically, so we will get some values. On the base of value only, we will decide that there is a strong correlation, there is a weak correlation, there is a no correlation. Okay. So we will discuss one by one. There is a scatter diagram and graphic method and algebraic methods. The first one, the scatter diagram method. So here, what is scatter diagram method? See, there is some diagram. So when we are using a scatter, nothing but when you are using some points or dots, in order to know that the correlation between the two variables, that is called a scatter diagram. Simple. The scatter diagram is also known as the dot diagram method. Dot diagram, nothing but the dots. Nothing but we can say that we can put dots when you have the data. So when you are taking into account the x variable on x axis, y variable on y axis, you may put the dots. So on the base of dots only, you will come to know that whether is there any relationship exist or not. So that is a scatter diagram. Scatter diagram is also known as a dot diagram method. Dot diagram method. Dot diagram method. A simple representation of the data between the two variables can be done by means of scatter diagram. So which is merely graphic representation or graphic presentation of the set of n given pairs of the observation on x-axis and y-axis. For example, if you take into account, if you take the data on x-axis and y-axis, for example, if they have given the two variables data, x variable data and y variable data. So if you take x variable data on x-axis, y variable data on y-axis, when you put that graph, nothing but when you put in the form of graph only, if you put the dots, for example, x is equal to 10, you can find out the x value is 10. If y is equal to 5 at a particular point of time, then y-axis is 5, x is 10. So where there's the two curves can intersect, so that point you can put it the dot. See, I can show you that. See, for example, I have taken the example. There's a years exports and imports of a particular commodity, for example. So I have taken 1988 to 2018 data. So from exports, and I want to see that whether there's a relationship between exports and imports. I want to know that particular countries, is there any relationship between exports and imports? Okay. So in order to know that whether there is an existing relationship or not, so I put the scatter diagram. Think about these diagrams. These are dots. For example, in a particular point, in a particular year, 1988, the year export, year wise imports. For example, if you take into consider, or year wise also, no problem. Year wise. So this is a year on x-axis. Year and y-axis, you can take the data. So similarly, in particular year, how much export and how much imports. So here, see, this the color is different from exports value and imports. See, dots. So on the base of two dots, we can come to know that there is a close relation between the exports and imports. But we cannot come to know what is the how much is the close. For example, we cannot say that 90% close, 60% close, or 95% close, or 85% close. But we can came to know that there is a relationship between the exports and imports. So on the base of this graph or dots, we can come to know that the both variables moving together, both variables moving together. So that is called positive correlation, because there is a positive direction. There is a positive correlation. But we cannot come to know that how much the positive, nothing but whether it's a 60% or 90% correlation existing between exports and imports. The next example, how to analyze a scatter diagram. For example, when we have the data, when you have the data and when you have the graph like this, how we can analyze the data, the diagram. The points are scattered lies on straight line having a positive or negative slope. So we cannot bother about whether negative or positive. But if the straight line, this is a straight line will be there, if the dots are very close to this line, if it is like this, it may be positive. If the straight line is like this, is a negative slope. If the dots are very close to the negative slope, it may be negative correlation. So here the dots are very close to the straight line, and we can say that there is a positive correlation existing between the exports and imports. Okay, then the correlation is said to be the positive and negative respectively. For example, if the straight line is negative or positive slope, we can say the positive correlation. Okay, when the straight line is negative, we can say the negative correlation. Okay, so on the base of this one, there is a positive correlation. If it is opposite, nothing but it is a, if the straight line is like this, nothing but here negative slope. So if the dots are around that straight line, we can say the negative correlation. Okay. Then see, for example, if you take another example also, see, so hours and test score. For example, if you are taking hours, nothing but if you are watching a movie, if you are watching a TV, how many hours you are spending on particular TV to watch some serials and some other any other things. So what is your test scores? Nothing but your marks. So if your watching time of TV is increases, your test score may be decreases because you cannot spend more time on the study. See here how it comes. See, it's a negative. Nothing but if you put the straight line, it becomes the negative correlation. Okay. Then second one, this is also very important. This is a graphic method. So when you observe this scatter diagram and the graphic method, more or less similar. But when you are putting the dots, that is scatter diagram. When you are putting a line, that is a graphic method. Simple. So graphic method will be done on that graph paper. See, by plotting the values of x two variables on a graph paper, you will get two curves. That is the one for x variable and another for y variable. For example, this your so see here. So I have changed this values earlier. This one, see here 9.6 and here there's a negative. Nothing but scores has been decreases. For example, if you are spending your time to study the number of study hours, you may get more marks. Okay, here I have changed the data. Don't confuse. See here. So when you are spending more time on study hours, nothing but when you allot your time to study, so your test score maybe increases. See here, this is a test average number of hours, how much you are spending per time to study. Then this is the marks. So here, when you are increasing your number of hours to study, you may going to get more marks. For example, if you are not studying, you are not spending any time, you may get 50 marks with your basic knowledge. If you spend one more hour extra, you may get 75 marks. So when you are spending more time, you may get more marks. Okay. So like this, there is a positive association between the two variables. Okay. Simple. You can plot a values of x on x-axis or y-axis. No problem. Doesn't mean. So you will get positive correlation. This is a graphic method. Is it clear? There's a graphic and scatter diagram. Sometimes they will ask the question that what are the methods to study the correlation? Graphic method, Karl Pearson method. See, both D, none of the above. Okay. So C is option is the right answer because we can study the correlation by using scatter diagram as well as Karl Pearson coefficient of correlation. Okay. Then third one, there is a mathematical or algebraical methods. Within the algebraic methods, the first one is the Karl Pearson's coefficient of correlation. So, which is very important coefficient of correlation to measure the association between the two variables. So, before knowing that, we need to understand who is the Karl Pearson. There, here the Karl Pearson is one of the great British statistician who developed a method of measuring linear relationship between the two variables. So the Karl Pearson, who is a British statistician, who developed a method of measuring the linear relationship between the variables. So he has tried so much to study how we can measure the relationship between the two variables. So in order to know the relationship between the two variables, so his efforts are very high. And the Karl Pearson's coefficient of correlation is denoted by RK, RK, or K should be in the lower letter, RK, RK. Nothing but so correlation coefficient indicate with R. Last class I have told you that the coefficient of correlation indicated with small r, capital R, no problem. So small r is nothing but sample correlation, capital R is nothing but population correlation. When you use the population data, you can use capital R, no problem. So here RK nothing but Karl Pearson's coefficient of correlation. RK nothing but Karl Pearson's coefficient of correlation. Then see how we can estimate the Karl Pearson coefficient. We need some formulas. See, there are three formulas are there. So the Karl Pearson coefficient formula, the first one is the RK is equal summation small x minus x bar into y minus y bar. Directly we can write summation of small x into y. Summation x into y, we can write it. So here small x, nothing but we can get x minus x bar. We can get small x. Nothing but so x value minus x bar, nothing but we are taking deviation from the actual value. Okay. That is y minus y bar, nothing but so y minus y bar, y is equal to nothing, whatever they can provide y value, y bar nothing but average value. So small y is equal to y minus y bar. Then under root summation x minus x bar whole square, or directly we can write summation small x square also we can write like this. Instead of writing x minus x bar, we can write x small x square whole square. Then into summation y minus y bar whole square, nothing but we can write summation y square also we can write it. Summation y square also we can write. So under root can be applicable to 1 or 2, no problem. If you write 1 only, no problem. If you write 2 also, no problem. So under root summation x square into under root of summation y square doesn't mean. Okay. So you can write like this also. It's one of the formula. You can note down. Then another formula, coefficient of correlation for the Karl Pearson. See, n into summation capital X and Y. Summation sum of x y minus sum of x and sum of y. Sum of x into sum of y divided by under root n into sum of x square minus sum of x whole square into n into sum of y square minus sum of y whole square. This is another formula. So we will do by using both formula also we can find out the correlation. Let's see how we can calculate also. This is a formula. See another formula, the Karl Pearson coefficient correlation is based on covariance and standard deviation. Covariance and standard deviation. So sometimes they will ask that question. The Karl Pearson coefficient of correlation is the ratio of covariance to the standard deviation of x and y variable. You can remember that the Karl Pearson coefficient of correlation is the ratio of covariance of x and y to the standard deviation of x and y. This is a ratio. There is a coefficient of variance x and y divided by standard deviation of x and into standard deviation of y. Remember. Then here the Karl Pearson coefficient of correlation is most widely used. So already I told you that the Karl Pearson coefficient of correlation is widely used method in practice. For example, most of the scholars and statistician and economist, econometricians, and most of the scholars and students, they can use the Karl Pearson's coefficient of correlation, which is widely used and accepted also, and it is considered as an ideal method. It is considered as a ideal method when we are doing such kind of other coefficient of correlation methods also there. When you're using coefficient of correlation, there's a Karl Pearson coefficient of correlation, so which is an ideal method, which is a ideal method. Then come to know that how we can estimate that Karl Pearson coefficient of correlation. For example, they will give the data like this: advertisement expenditure and sales. So, for example, if you're employee in particular company, if you take into account, for example, if you take Big Bazaar, okay, so you are an employee in a Big Bazaar, they will give the data to you that you can estimate that. So while they are giving while they are giving the advertisements, nothing but they are spending some amount on advertisements. So when their expenditure on advertisement increases, whether their sales are increase or decrease. For example, if you take into account daily, the most of the companies, they will give the advertisements because to their products. When they are spending lot of amount on expenditure, whether their sales are increase or decrease, they want to estimate nothing but they want to know that whether the expenditure on advertisements are impact on any sales or not. For example, if you take if you take into account in the rupees also, you can take simple term advertisement expenditure 1 rupee, 2 rupees, 3 rupees, 4 rupees, 5 rupees. So these are if you take day wise, for example, if you take 1 day, 2nd day, 3rd day, 4th day, 5th day, for example. So their sales, for example, when they are spending 1 rupee on advertisement, their sales 3. When they are spending 2 rupees on advertisement, their sales are 4. When they are spending 3 rupees, their sales will be 6. So when there's our expenditure is 4 rupees, the sales are 7. Then their expenditure is 5 rupees, the sales are 10. Then on the base of this data only, they want to estimate whether there's any relation between the two variables, advertisement expenditure and sales. Then we will go with the formula in order to estimate the Karl Pearson. See, this is a very simple formula: n into summation of x y minus summation x into y. Okay. Then here n is nothing but we need to find out number of observation. How many observation are we have taken? 1, 2, 3, 4, 5. Here now n is 5. Then n is over. Then sum is nothing but total. Sum of x into y. X into y. So here after calculating x into y, nothing but whatever x is here, y is here. So doesn't mean that if you take y here also no problem. Adjustment expenditure is y, no problem. Doesn't mean I have taken x and y. If you take y is here, x in here, no problem. The answer will be same. Okay. Say here x is equal, x into y. So x into y, x into y. Here I have taken. There is a working columns x into y. X into y nothing but x value into y value. 1 into 3, 3. 2 into sorry. Yeah, 8. Yeah, sorry, the typical mistake. See, 1 into 3, 3, 2 into 4, 8, 3 into 6, 18, 4 into 8, 28, 5 into 10, 50. So when you add this all the values, okay, when you add all these values, there is called sum of xy, sum of xy. So I didn't write here sum of xy. So when you calculate it, you will get 107. So sum of xy is where I have written 107. Here I have written sum of xy is equal to 107. Then it is over. Then sum of x, sum of x. So what is sum of x? You have to add all the values of x values. So 1 plus 2, 3, 3 plus 3, 9. So 6, 6 plus 4, 10, 10 plus 5, 15. Sum of x is equal to 15. I have written here. Then sum of y. So we can add all sum of y values. So if you add, you will get 30. Sum of y. So 3 plus 4, 7. 7 plus 3, 13. 13 plus 7, 20. 20 plus 10, 30. Like sum of y is equal to 30. Then this is over. Then we need to find out n is equal to 5. Sum of x square. Sum of x square. Here we need to find out x square. Whatever x is there, we need to find out x square. Nothing but 1 into 1, 1. 2 into 2, 4. 3 into 3, 9. 4 into 4, 16. 5 into 5, 25. When you add all these values, you will get sum of x square. Sum of x square. Sum of x square is how much? 55. So here sum of x is equal 55. Then here sum of x, nothing but sum of x is nothing but sum of x is whole square here. Sum of x whole square, nothing but 15. Sum of x is nothing but 15. So when you multiply sum of x square 15 into 15, 225. Then n is nothing but 5. Sum of y square. Y is nothing but y into y. Here, see, y into y, 3 into 3, 9. 4 into 4, 16. 6 into 6, 36. 7 into 7, 49. 10 into 10, 100. When you add all these values, you will get 210. 210. That is called sum of y square. Then sum of y square is over. Then sum of y whole square. Sum of y whole square. Sum of y is called how much? 30. 30 into 30, 900. Okay. Simple. After getting these values, if you substitute in the values in the this formula, you will get the RK value. See next slide. This is the equation. So I'm going to substitute this value. See, RK is equal. See, n is nothing but how much? 5. 5. Then sum of xy is equal to how much? Sum of xy is nothing but how much? 107. 5 into 107 minus, as it is equal to minus. Then sum of x is equal to how much? 15 into sum of y. 15 into 30. Then divide by under root. This under root symbol is equal. N is nothing but 5. 5 into sum of x square is how much? Sum of x square. Sum of x square is equal to 55. Here I have taken 55. Then minus, I taken minus. Then sum of x whole square. Sum of x whole square nothing but how much? Sum of x whole square nothing but 15 into 15, 225. Then here into. Then n is nothing but 5. 5 into sum of y square. Sum of y square is how much? 210. 5 into 210. Then minus I have taken as it is. Then sum of y whole square. Sum of y whole square is how much? 30 into 30, 900. Okay. Then next is equal RK is equal. So 5 into 107, 535 minus 15 into 30, 450. Divide by under root 5 into 55, 275 minus you can take 225 as it is, you can take. Then into you can take as it is. 5 into 210, 1050 minus 900 you can take as it is. The next RK is equal. See 535 minus 450, you get 85. Then under root 275 minus 225, you will get under root 50 into 1050, 900, 150. So then next step RK is equal 85 you can take as it is. Then if you cancel the 50, nothing under root 50. So when you can open the calculator. So if you not you can in your mobile also you can take under root value 50, you will get 7.07. Then under root of 150 also you will get, when you cancel the under root you will get 12.24. Then as it is you can take RK is equal 85. Then when you multiply 7.07 into 12.24, you will get, when you multiply these two values you will get 86.53. Okay. So when you cancel it 85 by 86.53, then you will get the RK is equal 0.9823. So it means that there is a 98% correlation between the two variables, we can say that. But RK is equal 0.98 because already I told you that the R value lies between -1 to +1. -1 to +1. So R value cannot exceeds +1 and -1. Okay. So here RK is equal 0.9823. So it means that 98.23% of the correlation between the two variable. Nothing but there is a correlation between the sales of the particular company and their expenditure on advertisements. So we can conclude that there is a strong and positive correlation between sales and advertisement expenditure in a particular company. Is it clear, dear students? Hello?
Yes, sir.
Usha Sri and Anirudh, Somnath, is it clear?
Yes, sir.
Yes, sir.
Yeah. Okay, thank you. Fine. Then, see, as I told you that last class, there is a R value lies between -1 to +1. Okay. So if R is equal to +1, this is a positive perfect. For example, here we got R is equal to 0.98, but it is not +1. Exact 1, if it is 1, we can say that perfect positive. But see, if R is equal to -1, we can say perfect negative. But R is equal to 0, there is an absence. But here, see, R is nearly equal to 1, +1. Here, R value is nearly +1. Okay. Then we can conclude that this shows the strong and significant positive correlation. Okay. So if it is R value is very close to 1 + 1, we can conclude that there is a strong and positive correlation existing between sales and advertisement expenditure of a big bazaar, for example. If you take into account as a company as a big bazaar. Then, for example, if you take R is nearly equal to -1, what will happen? Okay, well, if the R value is, if you get negative, then it shows the strong and significant negative correlation. When minus, there is a negative correlation. If there is a plus, there is a positive. But if you, the minus is, the R value is near to -1, we can conclude that there is a strong negative. Strong negative. For example, as I told you that when number of hours are spending on TV to watch that some movies or some other thing, your grade marks, your marks are going to decrease. So when you calculate that R value is negative, so if there is a, if you are spending more time to watch the TV serials and movies, your marks may be going to decrease. So definitely the R value may be come to near to -1. Then you can come to know that you can conclude that so there is a strong and negative correlation existing between the number of hours spent on TV and your marks. So we can conclude that if the person is going to increase the number of hours to watch the movies and serials, so we can conclude that the student may going to lose their marks. Okay, that kind of study we can conclude and we can study also. Is it fine? Is it clear? Am I clear now? So do you have any doubt, and
Yes,
you can
sir.
ask me. Okay, then see. So meanwhile, you can take this data. See, for example, they will give the data. There is a price and demand. So they can ask the above question, that is, find out the Karl Pearson's coefficient of correlation. Simple, they will ask the question. Find out the coefficient, Karl Pearson's coefficient of correlation for the following data. They will ask the question like this. So on the below table, they will ask, they will give only this price and demand. Price and demand. How we can calculate that Karl Pearson coefficient of correlation? This is another method. Okay. So can you are you taking the notes, please? You can take the notes. This one, this data. So you can take and okay. Uh, shall I do or can you do? Hello, hello, dear students. See here, in order to get
We
X
can
bar,
do, sir.
okay, no problem. You can do it. Okay, then you can post that your answer in the WhatsApp group. Okay, then I will come to know that whether the answer is right or wrong. Okay, okay.
Okay, sir.
Okay, sir.
So by following this, you can follow this formula because earlier we have followed a different formula. Okay. Fine. Then, for example, if you take into account for the other competitive exams, for example, if you write any other jail exam, DL exam, or other assistant professor exams, or UGC net exam or set exams, so they will ask the questions. For like I was shown only one example is given. The question they will ask like this: given sum of xy, small xy is equal 340, n is equal to 5, standard deviation of x is equal to 2, and standard deviation of y is equal to 50. The value of coefficient of correlation R is dash. So this question asked in the UGC net exam. They are given options: A is equal to 0.5, B is equal to 0.6, C is equal to 0.68, and D is equal to 0.75. Okay. So simple here we can remember this formula. The sum of small x into y. This is x minus x bar nothing but x minus x bar is nothing but small x. So when you take into account sum of x minus x bar, sorry, x into y, this is a 340. So simple, you can take R is equal to 340. Then under root value, nothing but the variance is nothing but under root of variance. Standard deviation is nothing but under root of variance. Under root of variance. So when they have given the standard deviation, there is the x and y. Simple, you can take into x into y. As I told you that covariance x into y. And they have given the n value, nothing but number of observations are there. Then 2 into 50, there is a small standard deviation x into y, 2 into 50, divide by 5. Then as you can take R is equal to 340, divide by 2 into 50, 100, divide by 5. Then you can take R is equal. So here, when you cancel 100 by 5, 20, right? Then, so R is equal to 340 divided by 20. So when you cancel it, R is equal to 240 by 20. Okay. Then you are going to get R is equal to 0.68. R is equal to 0.68. So the answer is C. Answer is C. Is it clear or hello?
It's clear, sir.
Yeah. Okay. If you have any doubt, you can ask me now. Regarding to the Karl Pearson coefficient of correlation. Any doubt? Okay.
Sir, can you please, may you please keep may you please keep the notes in the WhatsApp group, sir? All this notes.
I have prepared only in the PPT only. I don't prepare in the on papers.
No, sir, this PPT is enough to revise it again, sir. If you keep this PPT also, it's enough.
Okay, but meanwhile, some people may not able to download now. That's why I didn't. So anyway, I will try to post